Good morning to all of you. This is the webinar organized by Discover Us. It's the US edition. It's targeted at researchers in the US. My name is Koen De Bosschere. I'm the project coordinator of this project. And this is about collaboration with NSF, between the EU and NSF on concepts for distributed computing and swarm intelligence. Here in the meeting, you see all the speakers that will present today in this webinar. So I will start with the introduction. So the project is a so-called Coordination and Support Action, CSA, which is a project, a European project, which is meant to support the European Commission in the implementation of its policy. It started this year, runs for 30 months, has a budget of €1 million. It has 5 partners, and 3 of them are present in this webinar: Ghent University, CEA, and University of Padua. And we also have 3 staff members that support us during the execution of this project. This project is supported, some people will say powered by HiPEAC, and HiPEAC is a European network also funded by the European Commission of around 2,500 researchers in computing systems. We exist for 20 years, and it's a subset of this, of the principal investigators of this network that are running also this Discover Us project. I would like to say something about the logo. Of course, this is the European flag and the HiPEAC logo. As you can see, we add the US flag, and with a little bit of help of ChatGPT, Eneco came to this logo, where you see the blue of the European flag and also the blue of the HiPEAC logo. You see here the yellow accent that you will also find in the HiPEAC logo. And then, of course, the red stripes of the American flag. And here you see a D, and here you see a U, and Discover Us. So we say Discover Us, which means that the colleagues of the United States are invited to discover us here in Europe. I noticed that some people from the US call it Discover US, which means that you invite us, Europeans, to discover you in the United States. So you will find this logo all over the place. It's a project, so it has a work project, work packages, etc. We have 4 research areas. Here you see them in the horizontal bars: managing complexity through high level of abstraction, new concepts for distributed computing, swarm intelligence, a number of AI-based concepts for the organization of these systems, and then also work on collaborative programming frameworks and software development tools. So these are the challenges, and we have 4 activities in the project. So we have an activity on vision building, one on networking, bringing the 2 groups together, then research collaboration, which is working together, and then community management, which is more a management activity in the project. We have 4 work packages, as you can see here. We start with the work package number 1, which is the cooperative networking.
Koen, we didn't see your slide, it seems.
Oh, excuse me. I did not share my screen. You should have told me before. Share screen. Now you can see it, Mark?
Not yet.
Now it should
No,
be.
indeed. Now you're there at the start.
So I apologize for not having shared my screen. So here you see the speakers of today. I will quickly run through them. So this is the project that you heard. This is the logo. So of course you were not seeing what I was talking about. So here you see the red stripes, the D and the U, and the yellow accent here, Discover Us, Discover US. And here you see the 4 bars, horizontal bars, with the 4 challenges and the 4 activities that we want to implement or are going to be implement in this project. So this is the project in 1 picture. So you have WP1 is cooperative networking. So we will have in-person networking events, 2 or 3 per year. And then we will also have online or virtual webinars. These are the virtual events that we are organized once a month. Then we have the vision development. We have vision workshops. We got one last week, the first one, and we will also have coordination meetings between NSF and the officials of the European Commission. And that's the reason why we are here today, are the exchange programs, the calls and that we will launch, and also the evaluation of the proposals that we receive. And then of all the approved proposals, also the exchanges that will take place. So we will run through this circle a couple of times during the project. And then there's also the back office activities, which is the community building, the membership, and then also management, and then also the communication and dissemination activities of the project. This is the timeline. So this is this year, 2024. At this moment, we are in the middle of the year, early July. And what we did so far is we have been working on community building. We have now around 50 members on our website. And with these members, we have organized a vision workshop last week. And that vision workshop, the results of that workshop will lead to a white paper, which will be delivered by the end of the year. Now, even more important than the white paper are the calls that we will launch. So we will open a call in July, and the call will close in October. And that's actually the reason why we are here today, to explain how you can participate in these calls and how you can get the money to visit a colleague across the Atlantic Ocean to do some collaborative work. So that's the part on WP2 and WP4. In WP1, we have networking events. So every 6 months, we have an event, an in-person event. And in the meantime, we do monthly webinars, and this is webinar number 5. And then we also have these strategic meetings between the officials of the NSF and also the officials of the European Commission. In the second year, we will do 2 more calls. So this year is the trial call, I would say, to try out everything. And then next year, there will be 2 calls, one in the first half of the year, one in the second half of the year. And then in the third year, we will just wrap up the project. The collaboration of the third call will be executed then, and then we will finalize the project. Now, how can you participate? That's an important question. There's a website, discoverus.eu here, and here you can find under membership 3 tabs. So to become a member, you have to apply for membership. And if you apply, you have to, if you're are becoming a member, you have to comply with the membership charter, the members charter, which means that you commit to participate in 1 activity per year. This can be a webinar or a vision workshop or an exchange. And that's also that you agree with your name being put on the website of the project, and also to be added to the mailing list so that you can receive information from us. You can also check the members. So these are 20 members from North America, from the United States. They are in alphabetical order. This is the top of the list. You can see the names here. So that's how you're listed on the website. We have 20 from the United States, and from Europe, we have at this moment 33 members. So here you see the beginning of the list. How do you become a member? Yeah, well, you click on this tab, and then you see you have to enter your name, affiliation, contact information, and motivation. And you can upload a CV, and then the steering committee of the project will decide whether you are qualified to become a member. But you are, of course, you have to work in this area of distributed computing and swarm intelligence. So that's basically how it works. We meet every month. So within a month, you will have a sign of life from us telling you whether you are accepted as a member or not. So that's for the membership. The webinars, this is the 5th webinar, actually the 6th. We started with webinar 0. And this is a Discover Us presentation, US edition. We also did an EU edition in February. So these were 2 European projects that were presented, 2 and 3. And number 4 was SAGE, which is clearly US-based project that was presented in a webinar. So as a member, you are invited to contribute to a webinar, to organize one, to attend them, of course. So this is how we work for the virtual networking. The webinars are uploaded on a YouTube channel called HiPEAC TV, where we have a playlist for the Discover Us project. So this webinar will also be uploaded there. We also have a summer school, which is also a networking event. So this is part of the HiPEAC Summer School. This is the total HiPEAC Summer School, but we created a track in that HiPEAC Summer School consisting of 4 courses. And this will keep the participant busy for the whole week. So we have one on dependable computing systems, one on robust and adaptive edge AI systems, one on the SAGE project, and then hardware software co-optimization for machine learning at the edge. 2 American presenters or teachers, 2 US instructors. And these are the number of participants, so it's quite high, 75, 73, 106 for these courses. So, and this is also not only a training, but also a networking event. There will also be a dedicated Discover Us session to promote the project. The application's closed because it's taking place in 10 days. This was the prize, and also Discover Us provided 10 grants for students to attend this event. Then there was the workshop, the vision workshop, in which we were going to think about the kind of work we want to do in this project. It was taking place in a small hotel in central Italy. You see a picture. These are the people attending the workshop, 36 people who were locked up in the hotel and had been brainstorming for 2 days. You can see Jason here, I'm here, and Tullio, who is also in the meeting, is over there. This was the introduction. The partners had to introduce, or the participants had to introduce each other. We have here a discussion, an early discussion, and then of course we got the brainstorming sessions on separate tables and then a plenary at the end. And we finalized the workshop with a panel discussion where we were thinking about the takeaways of these workshops. And these takeaways will also be used to create the first call. And so then there are the exchanges, which is the purpose of today's meeting. We will send around 20 people from researchers from the EU to colleagues in the United States. And then the agreement we have with the NSF is that a similar number of US researchers will come and visit their EU counterparts also during the duration of the project. So we count about 20 in each direction, so that's about 40 in total. And later there's a presentation by Tullio on what we expect as proposals in this kind of exchanges. So this ends the introduction of the project. I propose that we keep the Q&A until the end of the session, because there might be questions on items, on elements that we will later explain in this webinar. So this is scheduled for today. What you heard was the introduction to Discover Us, and there will be 3 more short contributions. One by Marc Duranton on the HiPEAC Vision highlights. There will be one by Tullio Vardanega on the mechanics of the exchange program. And then last but not least, it will be Jason Hallstrom, who will explain how the US part of this project is going to work. So I'd suggest that we then switch to Marc. I will stop sharing my screen, Marc, so that you can share your screen. Yes.
Okay, so do you see my screen?
It's perfect.
Okay. So I will present you some highlight of the HiPEAC Vision. Why this? Because from the scientific point of view, this could be an example of some idea that in the scope of Discover Us, and that we could discuss how to augment it and how to complement it in the scope of Discover Us. Or Discover Us could go into different but at least that could be a starting point. So what is rationale of the HiPEAC vision? So we consider that after the web, after cyber physical system, after the cloud, IoT, digital twin, continuum of computing, metaverse, artificial intelligence, well, we say that the next evolution of the computing system will be a convergence of the key ingredient of all this technology into what we call the next computing paradigm. I know it's not perhaps the best word, but we didn't find a better. So if you have a better name, please, we will be welcome to use it. Or basically, it's how computing will experiment the world. So I will explain it more in detail here. So what are the drive? We see that an increased amount of data are being generated by interconnect machine. So we will have the machines, the systems that are generating data and be interconnected, and we still have humans that are using the web and the interconnection. And we will see that in the future, it will be a blurring between these two webs. So the web of machine will be blurred and will be merged with the web of humans. So, and typically the machines will be controlling or be linked with the physical world. So they will be really intertwined with the physical world. Take a machine, take a self-driving car as an example that will need to communicate to other car or to the infrastructure, but also to the driver and things like that. So that means that in computing system, we will need now to cope not only with the web requirement, but also with the CPS requirement, meaning real world constraints like safety, like real time, like latency, like location, and things like that. So this is important to have a new paradigm that could expand the classical computing into to take into account these new requirements. So these are new in the web context, but of course not new in the context of embedded on CPS system. And also one important thing is the notion of digital twins. Why? Because if you want to optimize the process, or if we want to forecast what is the best way to do something, you need to have data. And in some system, you cannot have, you could not put a sensor because either the device is not yet available or it's difficult to put sensor in a particular location. So it's why having a modelization of the device is important. So this is the digital twin. And the digital twin is also helpful to be able to manipulate variables that you cannot manipulate in the physical world, like time. Time, it only goes in one direction for us, perhaps unfortunately, but with a digital twin, you could go in the future, so to make prediction. So what will be the next, what will be the behavior of other car in 5 or 10 minutes to avoid traffic jam or things like that. Or you could go in the past to see what are the origin of the system. So it's an important element to be able to optimize system. And one other thing is the notion, and it's clearly linked also with the previous point, is that we consider that we need to have also a notion of space and time. Let me take a very simple example. Here I have an IoT a device here that gives me the temperature. Okay, but if I say it's 23 degrees, it means nothing. You need to know that it's 23 degrees in my office now. So that is why it's important to have not only the information, but the location of space and time. And again, I take the example of a self-driving car. So it has certain property, let's say in France, and in UK, it should have other properties. So to drive in the other side of the road. and things like that. So that's important. And there are already organizations like IEEE that are working in making standard for this. So this is, for example, the P2874 Spatial Web, which is working on a standard that could help to add protocol that cover this. And the other idea here is that everything will be seen as a service. So, and an application will be done by composing all the services. So typically, my smart thermometer will offer the service to give the temperature in my room every 5 seconds or things like that. So when you want to make an optimization, so you need to compose a service of this thermometer plus the service of the air conditioning together to make, okay, I want to have 23 degrees in my room here. And this organization of services need to be tailored to the need and to a particular requirements. So let's say that, for example, we want to preserve data. So I don't want to have my data sent to California or to China. I want to have it processed here. So this is very important also to have this notion of migration of data, but also of migration of code. So this is the point where we can basically say that here again, I take the example of the temperature. If I have a record of 1 year of temperature and I want to have the average, so I might have, I don't know, 1 gigabyte of data. It's very inefficient to send 1 gigabyte of data in a server from France. So I'm located in France to California to only do the average. It's far more efficient to move the average program to locally here and making the average with my local data here. And to be able to map all this, we need what we call a smart orchestrator here. So this is the key idea of this, and of course we need to have it into a sustainable economy point of view, and we need to see also how this could contribute to have a sustainable system, because yeah, it could allow by composition of service to increase the lifetime of system and to allow to save energy of matter. So in HiPEAC, we go a little bit further into this idea. So we're trying to define what are the stack. Here is a service plane and also all the interconnects. So as I told you about the spatial web, which is defining extension to HTML and HTTP, which is called the Hyperspatial Modeling Language, HSML and HSTP for Transport Protocol, and also the Universal Send Descriptor that is also here. So that could be the exchange. And we need also to have this orchestrator. And of course, here we could use artificial intelligence and agent like crew.ai or Autogen or other solution for making this orchestration. And of course, using artificial intelligence for the interface with human. So to conclude, what are the key elements for the next computing paradigm? We need to have a kind of interoperability on the requirement. So to go towards this 4D computing, so this computing which is spatial and time aware. So that means on the practical side to make extension to the existing protocol. We don't want to reinvent everything. So we could use HSML, HSTP, OpenUSD, and also adding this notion of timely delivery for this kind of safety critical function here. And we see that we have all these services, so we need to support also this kind of swarm-like aggregation, so opportunistic and dynamic aggregation of the compute node on the services to be able to perform a particular function with particular criteria. Of course, we have some requirement in terms of security, authentication, so contract-based, And also this idea of not moving only data, but also moving code goes to this idea of using a standard where execution could move, like WebAssembly, into a safe environment, so in sandboxed environment. So that's clearly the key element. So it's Halo computation to really move following the user and to find the best balance amongst various criteria such as latency, privacy, data freshness, energy requirement, and things like that. So really, this is high-level abstraction on standard that need to be defined, and this is perhaps some idea that we could work together into the framework of Discover Us. But we need also to have more concrete development. So for this orchestrator and for hardware, so that means also that we need to know how to efficiently design them. Is it using artificial intelligence? What are the framework tools? And this could be also a topic of discussion inside Discover Us. So just to conclude, what is the vision HiPEAC is that we are moving from, let's say, classical cloud computing, where most of the computing is done into a centralized cloud, to what we are now is that we have more intelligence at the edge, and we want to go really into more a swarm environment where we have a distribution on cooperative systems, so systems that cooperate together in an ad hoc functionality. So this is basically some of the key ideas that we were developing in the HiPEAC vision, and that could be discussed in the framework of Discover Us with how to implement them. How could we refine or improve this vision, or on the contrary, have an alternate vision? So that was the point that I wanted to share with you today.
Okay, thank you very much, Marc. So then we can move on to the next speaker, which is Tullio Vardanega. So maybe in the meantime, if you have questions, so we will do the questions at the end of the webinar. Feel free to enter them in the Q&A box. So I see there's already one question there. We will answer it at the end. Feel free to add more questions. Yes, Tullio.
All right. I understand that the screen I'm sharing is visible.
Yes, it is.
That's good. So I'll be starting. I'm impressed that Koen first and Marc after kept their own time slot. So I'm really due to be on time myself as well. Topic of this third part of this webinar today is what we call the exchange program. So this Discover Us, as Koen has indicated, is a project that is it's aimed at favoring technical and scientific collaboration between EU-based researchers and US-based researchers under the auspices of NSF on the US side. Let me see if I can advance. Yes, I can advance. And in this collaboration, in this exchange, as you notice at the top of the slide, I kind of gave emphasis to the consolidation. Within this 30-month project that is Discover Us, we would really like to not to sort of start something afresh out of nothing, but really try and give more energy to boost collaborations that are in the making, have already existed, could be reinforced. So consolidation is an important connotation of this, and we would like them to be lasting. That is to say, not to be limited to a 30-month, and in fact, it is less than 30 remaining months of a project, but lasting past it. So we would really are encouraging or seeking collaboration that have these characteristics. They're consolidating and they're lasting. And that's why we expect that it is more likely that they will be such if they are being proposed and promoted by researchers that are in place as staff, research staff in their own institution. Because the project has a EU side funded by European Commission money and a US side under controlled and promoted by the NSF. What I'm talking about here now is the EU side of the story. And then there is Jason later that will explain what is really the view of NSF on this in the way NSF can be in singing in the choir in this respect. We imagine within the duration of the project, about 20 exchanges in total. And we have a plan to have 3 calls for proposing, in fact, these exchanges. And we imagine that the EU side follows in sync or within a short latency on the same principle. The baseline of any such exchange, we expect it to be around 1 month. It is not that we are counting the days and the minute of that, but it is to be solid enough, but not, if you like, a sabbatical. So 1 month is an order of magnitude that would allow, on the basis of the budget that we have secured for this thing, to reach the region of 20 exchanges in the total duration of the project. Every such exchange would be expected to produce some output, and this output has to be concrete, but of course, concrete and also having potential to expand in the future. So examples are at the bottom of the slide, and I will not be repeating them. And if you people there have questions on this, we will answer more in detail. We expect proposals to be lightweight. We are not in Europe, we are not in the EU. We are not as lightweight as NSF, so we are not asking for a 1-pager for this. But what we expect in each such proposal is not exceeding 3 pages. So it's not really heavy effort in preparing the thing. We expect each such proposal to have 5 parts. One is the obvious, is to indicate who's the applicant, the person that is, in the case of the EU side part, the EU-based research that says, I would like to visit this particular host in the US. This is me, this is the host, and the scientific record of the applicant. And then what these exchanges planning to achieve, and the schedule in which this is going to take place, and then what outputs are promised, expected out of this stay, and what would be the post-visit commitments, the things that would continue to exist after the time of the visit has ended, and then a cost breakdown. I will have more on the cost in a moment. Then we'll have an evaluation procedure. And we expect, of course, to have many more than 20 proposal for exchanges, not to frustrate people, but to be able to really select what we deem, what the evaluation pool evaluators, will consider the best. The evaluation criteria are the obvious one. There is no rocket science in this. We would like to judge on the quality of objective. We would like to judge on the track record of the applicant. We would like to apply some weighing on the applicant so that we can balance out gender, seniority, and other ethical indices that we may like to consider. Of course, we want to consider the track record, not report, sorry for the typo, of the proposed host. And of course, we will be judging on the added value of a collaboration in the view of evaluators. The proposal will be ranked by global score, and we may apply cutoff criteria, and of course we would have a per year budget of the total amount of money that we would have to assign to this initiative. Evaluators and applicants will not know each other, and of course, and we will also have the evaluators not knowing themselves. And then what the evaluator will pass on as their recommendation will be passed to the steering committee of the Discover Us project to determine finally what will be the pool of proposal that will be passed in approval. And as noted, we would imagine that in the pool evaluators of the EU side proposal, we might include US members and expect that something in reciprocity may happen in the evaluation of the NSF side of things. Of course, if the admin rules in place would make that possible. The schedule, which is really the important part in the sense of this whole story. We would like to have a first call very, very soon. And we would like to have a third and final call by October. Reason is that we would like to be sorted at the final end of the project, which is in June 2026. We would like each such call to be 6 months apart of each other. The first call that inaugurates this exchange program, we would like it to be out very soon, mid-July, EU side of the thing. And considering that it is going to be summer when this opens, we would like it to close in mid-October, so giving time for the call to spread around and people to wake up and start, thinking and pondering what we'd like to propose and blah, blah, blah. And then the implication is that we'll have around a month of evaluation, making decisions. This implies that, in all likelihood, the earlier start of exchange is going to be for this first call in early January 2025. We'll have a second call in early 2025 with the outcome of the evaluation process for the second call by mid-April, and then subsequent start of exchanges. And then call 3, as noted, more or less in the same scheme, in the time scheme as call 1 in July and October. This is why we would encourage, in fact, we'll put it in the notice of the call, that the proposed visit should be scheduled to take place within 6 months from the time of when the proposal is made. And this closes my presentation on this topic.
Okay, thank you very much, Tullio. And then Jason, it's your turn.
Thanks, also. First, to our colleagues in the US, good morning. To our colleagues in Europe, good afternoon. So it's great to virtually see everyone participating today. The National Science Foundation is very pleased to be participating with HiPEAC and the European Commission in realizing Discover US and initiating this new collaboration between the European Union and the United States. So we're really excited about this. Today, NSF's investment in the program has focused primarily on travel support. So we have been able to support travel grants. We've been able to support supplements to allow participation of US researchers in events within Europe and within the broader Discover US initiative. Folks in the US understand how the National Science Foundation works. We are not a prescriptive foundation, so we generally do not set the priorities directly without input from the community. So we tend to rely on the community to help us understand where our investments most needed, and our involvement in Discover US will remain in that same spirit. So we're really looking to the community through these various ideation events and workshops that you've heard about today to understand from the community where there are the greatest opportunities for collaboration. So with that in mind, it's important to understand that the types of activities that could be supported through the National Science Foundation in the future as part of this initiative. This is being coordinated through the Division of Computer and Network Systems. And so I'm going to go through very quickly a brief overview of the topics that are supported through the Division of CNS, Computer and Network Systems. So the CNS mission is to support research and education activities that invent new computing and networking technologies and that explore new ways to make use of existing technologies. So we're interested in supporting work that provides a better understanding of the fundamental properties of computer and network systems to create better abstractions, tools for designing, building, analyzing, and measuring future systems. And we also support computing infrastructure that's required to enable experimental computer science, and we coordinate other cross-divisional activities that foster integration of research, education, and workforce development. CNS is organized along 5 primary areas. We refer to these as clusters, and I'm going to go through very quickly each of the 5 clusters within CNS. Again, the idea here is to help everyone understand the broad space of play that could be brought to bear in projects supported through this initiative. The first is my home cluster. This is Computer Systems Research, the Computer Systems Research Cluster, or CSR. The CSR mission, exactly as computer systems research sounds like, is to advance the holistic design and development of networked and integrated software and hardware computer systems. Our work that we support spans everything from low-level memory processors, instruction set architectures, all the way up through the application interface, but not including the applications themselves. We're certainly interested in supporting foundational computer systems research that is use-inspired, but we do not support applications that are focused entirely on the construction of a single application. We support work across a range of systems, completely consistent with what you've heard today, everything from resource lean IoT devices through edge, cloud, grid, clusters, all the way down embedded systems, real-time systems, many core, and everything in between. Our second cluster is the NETS cluster, Networking Technology and Systems. The NETS cluster invests in projects that advance the fundamental scientific and technological advances that lead to the development of future generation networks. We support both wired and wireless network systems, and again, we're interested in systems across the computing continuum. So this is everything from edge networks to cloud, internet scale, IoT, resource lean, highly resource constrained, and again, everything in between. We're focused on the continuum of computing. Our Secure and Trustworthy Cyberspace program is focused, or what we refer to as SATC, is focused on approaches to security and privacy. And we view this as a socio-technical problem that involves scientific and engineering problems, as well as vulnerabilities that arise from human behaviors. As you can see from this slide, SATC draws upon expertise across a broad range of domains, and we have engagement across a number of divisions and directorates within the foundation. Our Cyber Physical Systems program is focused on developing the core system science that's needed to reliably engineer complex cyber physical systems that involve a strong computational component and involvement with the physical world. The program supports investments that reveal cross-cutting fundamental scientific and engineering principles that underpin the integration of cyber and physical elements across application sectors. Many of you have seen this picture before, the picture on the right-hand side of the screen. This is our CPS flower. We look at CPS as the core of this flower, so that is control, safety, verification, design, networking, and all the other components that are required to enable the core of cyber physical systems. And then those advancements can apply across application sectors, or are applied across application sectors: smart and connected communities, manufacturing, agriculture, civil, materials, medical, energy, automotive, and others that are not listed. This is a multi-agency program that involves support from USDA NIFA, from the Department of Transportation, National Institutes of Health, and the Department of Homeland Security. CNS also manages research infrastructure programs, and our research infrastructure programs span a range of scales. So you may be familiar with the Major Research Instrumentation Program, MRI. There's also the CC STAR program, which is focused on community and campus-wide infrastructure. So this is campus cyber infrastructure. We also have the CIRC program. So this is Community Infrastructure for Research and Size. This is formerly our CCRI program. And then, of course, our largest scale initiatives are our mid-scale 1 and our mid-scale 2, which range in investment size from 4 to 20 million at the lower scale to 20 million to 100 million at the upper scale. This program is particularly important because one of the findings that came out of the discussions last week that we had in Italy with colleagues from the US and Europe was the importance of computing infrastructure as a catalyst for international collaboration. CNS also manages the Industry University Cooperative Research Centers program, or the IUCRC, and this is a unique program that is focused on driving innovation by facilitating partnerships between academia and industry, so that it provides a pathway for academics to understand where there are needs and opportunities in the space in which industry plays, and to provide an opportunity for collaborative investment in programs between those industry partners, the NSF, and the participating universities. Now, I mentioned that the NSF has already supported travel grants, travel supplements, and travel grants to allow U.S. participants to travel to Europe to participate and discover U.S. brainstorming and ideation events. We also have a so-called On the Street Today a Dear Colleague letter that is titled Research Collaboration Opportunity in Europe for NSF Recipients. If you wish to look this up, it's NSF 24-053. So this program is focused on supporting travel for US participants to spend time at ERC-funded research sites in Europe. Now, importantly, the European Commission has provided a list of ERC-funded principal investigators and research teams that have declared an interest in hosting NSF-funded researchers. And there are instructions at the link that's provided here for how you can access that list. So that's a list of folks in Europe who are excited by the opportunity to host US visitors. And this DCL provides an opportunity for existing NSF PIs to apply for travel support to participate in that exchange program. Now, we do anticipate other opportunities will be developed to support this initiative, but this is an opportunity that's available today to support US participation. And with that, thank you very much, and I'll turn it back to my European colleagues.
Thank you, Jason. Okay, so now we can move to the Q&A session. I see here that there are a few questions, a couple. The first question by Logesh is, does this membership allows global or restricted to US, Europe? The answer is that in theory, it is about a collaboration between US researchers and European researchers. It's also pre-competitive. So the main target group are not researchers in industry, for instance, that would like to come to Europe or vice versa. So it is more people at the university, preferably working in a particular project, an NSF-funded project, for instance, collaborating with people in the European side, also working in a publicly funded project. Now, obviously, most research in this area have projects, so that last condition will be fulfilled almost automatically. That said, if you want to collaborate, if you would like to become a member, but you do not fulfill that restriction or criteria, you can always contact us. Maybe there are good reasons to also take you on board, but that's something the steering committee will evaluate once they see an application from somebody who is not linked to one of these institutions. So I don't know whether that's an answer to your question. I hope so. If not, feel free to contact us and we will further elaborate on this. And the second question is, will the slide recordings be available? Yes, they will. This is a webinar. It's also recorded and we will put it on HiPEAC TV. And we will also send a mail to all the people who participated in this event to tell them where they can find the information. So, are there further questions? There are still some people, there are still people in the meeting. So I'm wondering whether there are more questions. Feel free to ask or to raise your hand, whatever. So I have a question maybe to myself, to Jason. So we will have a call in July. So do you want us to also promote that call among the US members that we have, or do you rather want people to make use of the Dear Colleague letter, which is not necessarily linked to this, but not necessarily linked to this project? So how do you see this?
So I think it's useful to disseminate the July 7th opportunity with US colleagues so they're aware of what's happening within the Discover US network. But those funds, of course, are restricted to support European researchers to travel to the US. But again, I think this creates a nice symmetry. So the ERC DCL provides an opportunity for folks who have declared an interest in hosting US folks to allow support for the US folks to travel. I think that the July 7th opportunity provides the reverse of that. So I think sharing this within the network creates an opportunity for US researchers potentially to reach out to European researchers within the Discover US network to declare their interest in hosting European researchers through the July 7th call. So I think that would be great.
Okay, good. That's very clear. So another thing that I would like to announce, so we got the first vision workshop in Italy this time. There is room for a second workshop, and we might also, well, we might decide to organize this workshop in the US to have some symmetry. So if there are people in the US who would show interest in helping us to organize it, feel free to contact us. We're more than happy to work with you and to make it into a successful workshop. Okay, so
I'll just mention that the bar is high. So the HiPEAC team did an amazing job last week. It was an excellent workshop.
Let's see. There's always room to put it even higher. No, but we will organize it, Jason. So it will be the same team organizing it. It just will be in another location. So we'll keep the bar high.
Excellent, excellent.
The food might be different. Okay. So are there more questions? I don't see questions. So then I suggest that we close the webinar here. So we will put the recording online, and you can further share it in your network for people who would like to collaborate in this project with us. But for sure, we will send well, something like between 5 and 10 people to the US normally in early next year. So in spring next year, that will happen. Okay. Thank you for joining.
Thank you.
Bye.
Thank you all.
Excellent. Bye bye.